looking at today, the main theorem here is called Hinge Theorem. The Hinge Theorem, it's also kind of like a swinging gate. Because Hinge Theorem, you can consider it as a gate opens. So as we open a gate, two sides, because kind of the triangle that's formed between it, so where the gate's actually open and the latch, we can consider as a third side of a triangle. As we open it, that other side of the triangle is going to get what? Bigger, yes. It's going to get wider, yes, because that length is going to increase. And the angle here at angle A, if we drew this triangle here, this angle is going to get bigger as the gate opens, yes? And the distance from this point here to this side is going to get bigger, yes? The two sides, the gate itself and the distance between the gate and the hinge, this side and this side are going to stay the same, yes? Because the gate door itself is not magically going to get bigger, and the distance between those isn't going to magically get bigger. Those are going to stay the same. And as I open it, that third side is going to get bigger. The angle is going to get bigger, yes? So what Hinge Theorem states, and what Hinge Theorem talks about and kind of proves, is that if two sides of one triangle are congruent to two sides of another, kind of I had two gates, and if one is open 88 degrees and the other is open 35 degrees, well, what do we think? Which side's going to be bigger, this side or this one? Well, the one that's what? Open 88 degrees, yes? Because if I have two triangles with two sets of congruent sides, the bigger angle is going to be opposite the bigger side. The smaller angle is going to be opposite the smaller side. That's it. Now, the converse of the Hinge theorem, if I have two triangles with two sets of congruent sides, the angle opposite the bigger side is going to be bigger than the angle opposite the smaller side, which is essentially the same thing. We're just going in reverse. That's it. Good. Again. Oh, other way. There we go. Given ST is congruent to PR, they have it drawn. But we can also say that PS is congruent to itself, yes? So these two triangles, I have two sets of congruent angles in each triangle, yes? They're two sets of congruent sides. Compare PST to angle STR. So SR and PT, which one's bigger? SR or PT? PT is 24, SR is 23, yes? So the bigger one is PT. So which angle is going to be bigger? PST, because it's opposite the bigger side, yes? So angle PST is what? Greater than angle STR. That's it. That's it. Questions on this here? Over black? All right, let's look at this next one here. So we have two sets of congruent sides in the triangle, and we want to compare angle B, the measure of angle B, to the measure of angle E. So we need to look at the side, see which one's bigger. Is AC or DF bigger? AC, because it's 11. So the angle opposite AC is going to be bigger. So that tells me what? angle B is going to be bigger than angle E because its side is bigger. And that's it. Questions on this here? You ready for the next one? Okay, this one here, now we're going to look at the angles. Well, not the angles, the sides. So we're told that JK and LK are congruent. Well, I know that KM is congruent to itself. So we're really comparing JM and LM. JM and LM. So which angle is bigger? Well, the 64-degree angle is bigger, yes? And the side opposite the 64 degrees is JM. So JM is bigger than LM. And that's it. Okay, so again, we're seeing which angle is bigger. Because there are 47 and 48. All right, guys, so when we look at this here, angle, the 48-degree angle is the bigger angle, yes? And the side opposite it would be AC, so the bigger side is AC. So AC is greater than DC. And that's it. Questions on this here? You good with this here? Okay, well, looking at this here, if PR is equal to PS, and the measure of angle QPR is greater than the measure of angle QPS, which is longer? Which is the bigger side? SQ or QR? RQ or QR, that's the bigger side. Because when we look at this here, we're saying QPR. QPR, this here is the bigger angle. So RQ has to be the bigger side. That's it. Actually, right, it's more accurate. Any questions on this here? I feel like we're good with these here, yes? Okay, I'm not going to bore you with the proof, and I feel like we've gotten most of this handled, yes? Okay, so we're going to look at this last one here. Now, this here is a real-world problem, real-life problem, and they're going to call any problem that we can actually have some application to it, not just looking at figures, not looking at just pure numbers, a real-world problem. Now, two groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles and then changes direction and travels 1.2 miles. So what we're saying is these here are the same and these here are the same. So I have two triangles with two congruent sides. Now group A starts due east, then turns 45 degrees north. And group B starts due west and then travels 30 degrees south. Now our angles are going to be 150 and 135. It's going to be 150 and 135. Because when we talk about a change in that direction, north, south, what they're really saying is from this direction here that this angle over here on the outside is 45, this angle out here is 30. Well, they make a straight line, yes? And I'm not really worried about the angle on the outside. I want to know the angle inside. So I took 180 and subtracted 30, which gave us 150. I did the same thing with 45. 180 minus 45 will give us 135. That's how we come about those two angles. Now what we want to know is, as the crow flies, which group is farther away from the camp? Well, which one of these has the bigger angle? Group B. So group B is farther away than group A because they had the bigger angle, yes? And we have to be careful with it. Just because they give us the angle doesn't mean it's our actual direction. So for these here, and some of these here, you might have these on the homework, you have to account for that there because they're going down. It's actually that angle minus 180 to get the angle inside the triangle. Questions on this here? This kind of makes sense here? Yes? Group C. Group C leaves camp and travels 2 miles due north. 2 miles due north, and then turns 40 degrees east and travels our 1.2. You don't have to write this yet because, again, I'm going to have to move this around because we're adding group C into the mix. Now we knew group B was 150 degrees. Group A was 135. So if group C traveled the longest, it would have to have an angle greater than 150. Does it has an angle greater than 150? Then it's the biggest side, yes? But I don't know the angle yet, this here. Because to find it, I have to do what? I have to take 180 and subtract 40. What's 180 minus 40? 140. So this angle here is 140 degrees. Is that bigger than group B? Did they go farther than group B did? Well, no, because 140 is not bigger than 150. Did they go farther than group A? Are they farther away from the camp? Yes. So if we were looking at this, group B is bigger than group C, but group C is greater than group A. And that's it. Questions on this here? Any questions on any of this here so far? All right, we're going to do this one more time. We added group D into the mix because we're going to go all 4 directions, north, south, east, and west. Now, so far, we've said group B was greater than group C, which was greater than group A. I'll move this up here. We'll come back to it later. Now, group D traveled 2 miles south and then turned east 25 degrees. So our angle on the outside is 25 degrees. So what do you guys think? Is this going to be bigger than any of these here or smaller? Well, that angle is smaller, yes? But I am still concerned about the angle inside of the triangle, yes? So to find it, I'm going to have to take 180 and subtract 25. 7, 10 gives me 5. So the angle inside of the triangle is 155 degrees. We had 150, 140, and then this one here was 135. So how does 155 rank among these? It's the biggest, yes? So that means out of all of these here, move this down. If we were to add group D into the mix, well, group D is going to be bigger than all the rest. Questions on this here? Any questions on any of this here? And that's it. That's all we're going to do. Now, obviously, you saw homework on whatever, but since we're not doing it out of the textbook, that doesn't mean anything. So your homework is already posted up on Big Ideas Math. You can go on and get started there. And we are done with Chapter 6. Tomorrow is going to be something a little bit different.